Lesson 8.3, attempting to pick up where we left off yesterday. As I was just saying, I rewrote example 3 this morning during homeroom. And I know we had, if I just kind of review it as you make sure you have everything up there, I said I did want to draw the picture. So we are still going to do that. So we're not totally done here. But it asked us to write the equation. We talked about the transverse axis has endpoints. So one correlation we made is that the transverse axis endpoints are called the vertices. We talked about because the -1 is the same, that told us it was the left column. Okay. Conjugate axis has length 8. That was the easy one, right? So 2b equals 8, and thus b equals 4. Transverse axis. How did I know the transverse axis had a length of 10? It didn't tell me that. But what did it tell me? We had transverse axis endpoints at -2, so 2 left, and at 8, so 8 right. And that's a difference of 10, isn't it? So we knew our transverse axis was 10 long, which is a difference of 5. And then, again, we haven't drawn the picture yet, which I want to do. What I asked you guys is, okay, what's in the middle between -2, -1, so left 2, down 1, and 8, -1, so right 8, down 1. And we talked about -2 to 8 being 10 apart, count in 5, and that puts us at 3, -1. I wrote the equation up here. X minus 3 squared over 25 minus y plus 1 squared over 16 equals 1. I don't think you guys had a problem writing that because we already had all the information when we left yesterday, right? Now, I do want to take a moment and let's look at the graph version of this. Okay, so I kind of set up my axis. I know I have to be able to go 2 left. I know I have to be able to go 8 right. I'm going to end up having to be able to go 3 up and 5 down, it appears. Again, I encourage you to practice graphing this. This might be the only other graph we do today, I think. So make sure you know how to go about this. So if we go based on what they say, transverse axis endpoints, or transverse axis has endpoints at -2, -1. So if I graph that, and at 8, -1. I need you guys to realize transverse axis endpoints are the same as saying these are the vertices, right? Those are the vertices. If you are a picture person and you didn't like how we found the center, here's where you find the center. Because, can I count how far apart -2 and 8 are? I can, right? And if I count those, they are 10 apart. So if you meet in the middle, count in 5. 1, 2, 3, 4, 5. We end up right there, don't we? Which puts us at the point of 3, -1, and that is my center. That right there, if your center is halfway in between your vertices, realize that this distance out to here And that distance out to there, that is your A equals 5 value. And so those are my A values. Remember, I want you drawing the box, or that's my suggestion, especially on this one because we're not staring at 0, 0. How do I find the other side of the box? We know we went out A is 5, in this case horizontally. What else do we have to go out? What's our other value here? B is 4. Okay. A goes out horizontally in this one. That means B goes out vertically. And so these B values, I'm going to count up 4, which puts me at 3. And we're going to go down 4, which puts me at -5. Those are B's. In order to do this, we need to draw the asymptotes. In order to draw the asymptotes, I'm going to draw my rectangle. My rectangle is going to go through my A values and my B values. And there's my approximate rectangle. Maybe I shouldn't have drawn those extra lines in, but okay. What do they say about asymptotes? They go where? They have to go through the center point, and they have to go through the 2 diagonals. Take the effort, as opposed to just throwing the lines on there all crazy like, to make sure they go through those, they connect those 3 points, the diagonals and the center. Same thing on the other one. And which way is my hyperbola going? Is it going up and down or left and right? Left and right. My vertices are at the ends, yes. The transverse axis endpoints are at the end. So I'm going to use my transverse axis endpoints, and I'm going to use that to draw my hyperbola. Notice I'm taking my hyperbola out along the asymptotes. Okay. Keep working to put all this information together. Yes?
So for simplicity's sake, when we're graphing, instead of doing the rectangle, can we just put a point at where like the imaginary corners on the box would be and then connect it? For like if you're asking to show a graph on like a test, can we do it that way, or do you want to see the box?
Good question. And I guess as long as they're accurate, it's okay. So Ethan was asking about just putting the corners of the boxes and make sure you go through the corners of the boxes, which I get makes sense. I'm trying to think from the grading perspective, because what I usually check when I grade is, okay, did you put your sides of the boxes at the right spots, and then are your asymptotes going through there? That might be a better question to ask me come review worksheet time, if that makes sense. Because if you show me one on the review worksheet, you know, like we can sit and look at it on the review worksheet and I can decide if that would work or not. Okay? I don't have a definite answer. I like the box for grading purposes, but I don't know technically that you have to have the box there. So I might be able to let you slide without it. I'm seeing what you're saying. Okay. We ready for example 4? They give us the equation. And we're being asked to find the center, vertices, and foci. Let's start with which column is this? Left column? Even though the 49 is under the Y? He's still nodding yes at me. He's not going to change his mind. Okay. Why is this left column? Because it's x minus y. Exactly. Okay. It's not about the bigger number. If this was x squared plus y squared, then we'd have to look at the bigger number to determine. But because it's x squared minus y squared, this is left column. So this is of the form x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay. What can you tell me here? We need center, vertices, and foci. I guess I would say let's go ahead and identify what we know. What's h? -2. It comes from the x. What is k?
5.
K is 5. Comes from the y. What is a? 3. Square root of 9 is 3, and that goes under the first fraction. What is b? 7. Square root of 49. Am I going to have to know c? Yeah, we're going to have to know c because I see the word foci. Anytime I see the word vertices, I think a. Anytime I see the word foci, I think c. So what is my Pythagorean relationship for hyperbolas? C squared equals a squared plus b squared. Know which one you're working with, right? So c squared is 9 plus 49. C squared is 58. C is the square root of 58. Okay. I was thinking there might be a perfect square in there, but I don't have one written down. So, what is my center?
-2.
Yeah, it's HK. And in this case, HK is -2,5. Okay. Vertices. How do I find vertices? Because we're in the left column, this is going to be H plus or minus A, comma K. Did you do the math here? -2 plus or minus 3, comma 5. Did you stop here? No. We can't stop here because that 3 is 3. We can add and subtract those values. So let's see. -2 plus 3 is 1. Why did I just write negative? Okay. 1, comma 5. -2 minus 3 is -5, comma 5. So those are going to be your vertices. The other piece of information we're asked to find are foci. So if last time one was h plus or minus a, we're going to do h plus or minus c, comma k. H, -2 plus or minus square root of 58, comma, k is 5. Do we go farther with these? No. Square root of 58 is just that. Unless you are trying to graph those values, we don't need to go farther. Okay. You're seeing hyperbolas are a lot like ellipses, aren't they? Very similar. Okay. Last page. Guess what? This last page is a lot like the ellipse last page. Just like the ellipse last page, I'm only going to do one of these examples. They're big, right? They take time. As a class, we'll do one and get you head in the right track here. It's graph the following hyperbolas, stating their vertices, foci, asymptotes, and eccentricity. So actually with ellipses, it said show that it's an ellipse. Still, it was telling you it was ellipse. We had to get in that form. Well, in order to be able to do vertices, foci, asymptotes, we need to get it in that standard form. Last time I said start off by grouping x terms, group y terms, and then move any constants to the right if they're not already there. The one thing I would say with hyperbolas, whichever variable has the positive square, that needs to be your first group. Whichever has the negative square needs to be your second group. And does that make sense to you? Because we're going to do x squared minus y squared or y squared minus x squared. So in this case, A is a pretty good example to look at. Do I want to group my x's or y's first? Y squared has the positive, so I'm going to group my y's first. I'm going to say y squared plus 6y. I'm going to leave a gap. I'm going to say it is minus 3x squared plus 6x. I'm going to leave a gap. I already have 18 on the right, and it doesn't look like I have any other constants. Everything's taken care of at that point, isn't it? If I had any other constants, I'd move them over to join 18. Now, before we can complete the square, what form do I tell you that we need to think about? It needs to be a 1x squared plus bx, or a 1y squared plus by. My y's are good to go. It's already a 1y squared. I don't need to worry about them. What about my x's? It's not a 1x squared. How do I make that a 1x squared? We're going to factor out a. Three, but specifically on that second set, you always want to factor out the negative. So even if it's just a 1 there, you want to factor it out and make it a positive 1, so you need to factor out -1. In this case, I'm going to factor out -3. When I factor out -3, it's x squared, and then what? If it was plus 6x and I factor out -3, it's going to be minus 2x. Leave a gap in those parentheses, and I still have equals 18. How do I complete the square? B over 2 quantity squared. So, with my y's, b is 6. What am I going to add to complete the square if b is 6? I don't know, will it help if I write it out? Although I think you guys are just all working on your own, aren't you? 6 divided by 2 is 3. 3 squared is 9. If I add 9 on the left, we're going to add 9 on the right. X's, repeat the process. In this case, you're using the current B, what you have after you factored. B is negative 2. So negative 2 divided by 2, quantity squared. It's going to be negative 1 squared, so positive 1. So here with the X's in the parentheses, I'm going to add 1. If I add 1 on the left, what am I going to add on the right? Essentially negative 3, isn't it? Because I'm going to add 1, but it ends up being 1 times negative 3. Because this 1 in my parentheses is being multiplied by a negative 3. So that other piece, that second piece here, you'll always end up adding a negative because there'll always be a negative right there. Okay, let's factor. Y squared plus 6y plus 9 factors into square root of y squared is y, square root of 9 is 3, and it was a positive 6. So y plus 3 squared. Minus 3 just carries down. My x's factor into square root of x squared is x. Square root of 1 is 1. The 2 had a minus, so we're going to say x minus 1 quantity squared equals 24. Hey, it agrees with my answer key. 18 plus 9 is 27, and then it ends up being minus 3. What's that last step to get this in standard form? Yeah, we need it to equal 1. So we're going to divide by 24, which means I'm dividing all 3 pieces by 24. Scribbling out B here, so okay, my equation, y plus 3 squared over 24 minus, that middle sign should always be a minus. Since it's 3 over 24, that's going to end up being 1/8, or in other words, an 8 in the denominator. So minus x minus 1 squared over 8 equals 1. There is your standard form. There's your standard form you're going to use for the rest of this problem. Left column or right column then? And this is a right column. And it's right column because it's y squared minus x squared. Just realized I don't even have this one done in my notes. I must have ran out of time last year. Interesting. Okay, well, let's go ahead and write our information down. H is what? One, because it comes from the x. K is -3. It comes from the y. A is square root of 24. Depending on the situation, you could leave it like that, square root of 24, or what does square root of 24 become? It's 4 times 6, and the square root of 4 is 2, so 2 square root of 6. B comes from the second fraction, square root of 8, and the square root of 8 is going to be 4 times 2. The square root of 4 is 2, so 2 square root of 2. And I see the word foci up there, so I know I'm going to need to have C. So C squared equals Pythagorean relationship, A squared plus B squared. C squared equals 24 plus 8. C squared equals 32. So C is the square root of 32. Did you guys simplify it?
4 square root of.
Officially 32, your best bet is 16 times 2, which is 4 square root of 2. It's also 4 times 8, and then you just have to break the 8 up again. Okay. First piece, vertices. Okay, vertices. Formula I'm using is H. Which way are we? We are right column, so am I correct in thinking it's H, comma, K plus or minus A? Yes. So I'm going to say 1 comma negative 3 plus or minus square root of 24. You could also write that as 1 comma negative 3 plus or minus 2 square root of 6. But you can't really go anywhere past that, can you? Okay, again, unless you're going to go decimal. So I would be just fine with this answer, but I'm also fine with that answer. Okay. What's the only difference between vertices and foci? Replace A with C. So I'm going to have 1 comma negative 3 plus or minus square root of 32, or 1 comma negative 3 plus or minus, not 2, 4 square root of 2. Again, I am fine if you don't simplify the radical. They don't really require it in this lesson. It's also that right there. Okay, that was foci. Ooh, here's a fun one we haven't done before. Asymptotes. Double checking myself. I think I know what form I've left this in before, but I don't have this in my notes right now. They're not done for whatever reason. Okay, I did. So if you go back and grab your asymptotes formula, right, there's a formula right there. It's not magic or anything. Go back and check out your right column. And we're going to have y equals plus or minus. And the main difference is it A over B or B over A? In this case, it's A over B parentheses, x minus h plus k. So fill in your a, b, h, and k, plus or minus. You could use either form of a and b, but I am going to have you simplify that fraction, which either way is going to be pretty easy to do. Honestly, it might be just as easy as, say, square root of 24. Wait. Yeah, over square root of 8. X minus h, which is 1, plus k is going to be minus 3. I would rewrite that and say y equals plus or minus, what would square root of 24 divided by square root of 8 be? Square root of 3. Times x minus 1 minus 3. So this one has a slope of square root of 3. For the asymptotes, that is. I would leave it just like that. Are we okay with asymptotes? I'm going to pause there for a moment because that's not something we've been doing every time, right? Foci, vertices, that's a piece of cake by now, I think. I hope. Realizing I kind of went through asymptotes quickly, but it's similar. You plug in the a, b, the h, and k. It's not anything fancy. We've got one more piece we're asked to find, and that is eccentricity. Eccentricity formula. Doesn't matter if we're talking ellipses or hyperbolas. E equals c over a. I don't know that it, trying to decide what would be better here. I don't know that it matters if you use the simplified versions or the non-simplified versions here. If we just go with c as square root of 32 and a as square root of 24. You do need to keep going and reduce that a little bit. What do you know about 32 over 24? They're both under radicals, so what is 32 over 24 reduced to? They both divide by 8. If they both divide by 8, that's going to be 4/3. What do you know about the square root of 4? Square root of 4 is 2. So I could possibly say 2 over square root of 3. Or how do I rationalize? If we're going to rationalize, how do you get rid of a square root of 3 in the denominator? You multiply by itself, square root of 3. If you multiply the top by square root of the bottom by square root of 3, we're going to multiply the top by square root of 3. And so then 2 times square root of 3 is 2 square root of 3 over, what is square root of 3 times square root of 3? That is 3. Okay. If you haven't already written the homework down, now would be an awesome time to do that, right? I'm going to squeeze it in over here in case you need it. Page 609. Numbers 2, 4, 6, 7 through 10. (24 to 42) evens 49 and 50, and you cannot forget to omit number 34. I like that word omit. But in case you missed it yesterday, what does the word omit mean?
Not
Skip, not do. So you're going to skip 34. There, I'll even write it down right there. Okay. You actually have like 6 minutes of class left, which is
unheard of.
unheard of, isn't it? I hate that, but it is.